Okay, so today's session is about VPN, IPsec VPN, very important and very difficult as well, honestly speaking. Make sure you know everything what we are discussing. So Oleg, you were saying something. So what is VPN?
So that actually, because the public network is not secure, and to provide secure network between local networks, for example, some branch network and office, we can create a VPN. This is virtual private network, which allowed us, which can to forward to this network secure traffic. And I don't know.
Okay, that's fine. Shafaqat, any idea? Would you like to share your thoughts about what is VPN? We just discussed about the VPN, virtual private network. Why we call it private and why we call it virtual?
Virtual is basically because this is the logical connection, it's not physical connection.
Okay.
That's why it's virtual. And the private, because it's a private tunnel. That's why it's called the VPN, because a private dedicated link or dedicated communication between 2 points or node or whatever.
Okay.
Because it's encrypted as well. So
okay. We'll come back to encryption, but right now we're just talking about just a generic term of virtual private network. What is virtual private network? Okay. Any Riaz, any thoughts about your side?
And also because the internet is not secure, so that's why we have to use the VPN, virtual private network, to communicate securely.
Yeah.
Just to encrypt and decrypting the secure data from client to server.
Okay, fine. Thank you very much. Whatever you guys have so far information, that's fine. Everybody has some idea. So first of all, virtual private networks are many types, but we're just discussing just discuss about what is virtual private network. What is mean by virtual private network? So as I think somebody mentioned, it's a virtual. So like, for example, when you connect one side, let's say this is a London side and this is a New York side. Okay, so this is London side and this is the New York side. When you connect these sides, actually, what you need a physical connection. Maybe you have to buy a one connection from level 3 from any other provider or BT. They provide you direct connection from here to London, and you can connect these guys together. Okay, and these are the offices. And what happened normally, mostly companies, actually the different providers like BT, Virgin, Verizon, these telecoms companies, they connect to the different networks actually to each other. And they can have a very expensive, but these lines are very, very expensive all the time. And this is a dedicated line just for only them. Nobody else is sharing, right? What is a shared network? Like, we have a shared network. We have the big major shared network is internet. If we talk about that, internet is one of the biggest network in the world. And it's a shared network. It's not dedicated network. But if you talk about just two companies, when they connect their offices to each other, they use the private network, like private lines actually. But keep in mind, these lines are very expensive. Yeah, these lines are very, very expensive. When they buy these lines, every company has to pay a lot of money, monthly, yearly, whatever they decide to that. Okay, but this line is for them. Nobody is else sharing that. But that's why this is a private to them. It's like a private road. Let's say if somebody is a very, very rich and he wants to build his own private roads, so nobody else's car can go into this road. So of course he need to build it himself. The government is not going to build them. So in that case, this is dedicated to him, and that's why this lines is totally secured as well. You got my idea? So they are totally secure, and they are they don't need to worry about most of the time about the security. But whenever you connect with the internet, number one, it's cheap. Why? Because internet is readily available everywhere. You need TSL, you have a private line as well, and you can connect the site with each other through using the public networks. So just a virtual private network, what is that? So it's a network, but it's a private network. Like mostly companies, they can connect to the network to each other by using the public media. Okay, so and there are different types actually, as we discussed. Okay. Okay, so for example, you can see generic GRE. I'm sure CCNA level you already discussed about GRE. There is MPLS tunnel nowadays as well. There is IPsec. Our topic is just about the IPsec tunnel. Okay, we're not discussing any other tunnel apart from IPsec today. GRE is all. I think you already done this in the CCNA. MPLS is the service provider topic. Yeah. So one of our favorite topics always MPLS. It is also build a tunnel between the two endpoints. Okay, but of course it's not secure. But there are other issues. But right now we're just talking about the internet. So this guy has a LAN and this guy has a LAN network. They have their private network. What do you mean by private network? They have RFC 1918. Okay, the 10 range, 192 range, and 172 range. I think yesterday we discussed about that when we were doing the NAT. So then these private networks can reach to each other by using the internet. Clear? Okay, and this is very cheap. Of course, this media is available everywhere. Somebody can have just 10 meg here and maybe 2 meg here. They can still connect and then can communicate to each other. The other good thing is the private network, like the 10 range and 10/8, right? 172/12. I'm sure you guys know about that. These private IP addresses on the publicly, they are not routable. Remember that? I think yesterday we discussed. Oleg?
Yeah, sure.
Shafaqat, these private IP addresses are not routable. So what we do, we kind of build some kind of tunnel here. So these private addresses goes inside the tunnel, and then they transport over this network, and they can communicate to other side. Also, this tunnel.
Yeah, man. This private network 172 should be /16 or /12.
I believe it's /12 or /16.
/16, I think.
Yeah. It is but if you talk about RFC /12, but generally it's a /16 as well. Yes, right? You're right. Okay. Anyhow, so whatever the private networks we have here, 192 network, for example, they can go inside the tunnel between the two endpoints. This is the endpoint and this is the endpoint. Maybe there are many routers coming across, but it look like they are directly connected to each other. Okay, so this is the tunnel, right? So the traffic goes inside the tunnel, it will be transported inside the tunnel, and the endpoint, they just feel they are just directly connected. But anyway, the actual data is going through many hops inside. Clear? Any question? Okay. So today topic, of course, we are just talking about the site-to-site IPsec tunnel. So we have different types of VPNs, remote VPN and site-to-site tunnel VPN. The remote VPN where you already guys have connected to our lab network. So I believe you already know about that. About site-to-site VPN, where one site connect to another site. It can be like another. For example, I can give you an example. Let's say some customer, for example, HSBC Bank. For example, there are Lloyds Bank. They want to provide these services to third party. For example, insurance company, they have many other clients as well, and what they do is kind of extranet. Okay, it's a third party or partners. So they can use they build the IPsec tunnel through the VPN, through the internet, and then they can transfer the data to each other in a secured fashion by using the public media. So when you need to transfer large amount of data between each others, you use site-to-site tunnel. When you use remote VPN, mostly used for telecommuter, when you just connect to the LAN network through maybe using some software as you are doing, in that case, you also use the remote access VPN. Okay, at this point, everything is clear?
Yeah.
Okay, so host send and receive normal TCP traffic through the VPN gateway. We already cleared that. Remote is, we already know, this is the remote software I think we're already using. So no question. That's ISSL VPN is not our topic, so leave it there. We also these so not interested in these as well. IPsec client can be many, like Cisco PDA, like computers, like routers, and different even sorts as well. Okay, this is GRE VPN, and the GRE. What is the difference between GRE VPN tunnel and the IPsec tunnel?
I think GRE tunnel is you can create only one tunnel at a time.
No.
Or in the IPsec, you can create one tunnel.
No, GRE is also a tunnel. It's a transport. It takes the transport.
But no security.
Number one, it is exactly, yeah. It does not provide you the security. Okay, the security is not guaranteed. It's IP packet anyway, but using the GRE tunnel, GRE encapsulation on top of it. Okay. So we're not interested. The GRE configuration is very, very simple, guys. I'm sure you already know that. Okay. So we're not discussing about GRE. Okay, this is our topic. Main topic is IPsec. Okay. So IPsec topology. As you can see, the IP topology can be many. Cisco routers to connecting to this. So let's say this is the main site. Actually, all these sites, they have their small routers, and they connect to the remote site or the main sites, actually head office sites, and they're using the IPsec tunnel to communicate to each other and share that data. They can be like, as you can see, Cisco router, maybe a small DSL router, fixed firewall can be, Cisco router can be. So there are many endpoints. So VPN tunnel can be built between Cisco firewall to firewall, firewall to router, firewall to maybe Juniper firewall, firewall to checkpoint, firewall, Cisco ASA to many endpoints. Okay, so it is all, as long as they support the IPsec. That's all they need, because IPsec is a framework, it's a standard. Okay, it's not proprietary to any vendor. Okay, work at the network layer, protecting and authenticating the IP packet. It is a framework, open standard, of course. It's providing the confidentiality, data integrity, and origin authentication. Three things. If you, as I discussed, guys, before, if you connect the VPN, if you connect different sites to each other, guys, can you please mute it yourself? Who's sorry?
It's not from my side. I don't know who is.
Okay. So anyway, so what we're doing actually, when we connect two sites together, as I said, using the as I previously given the example, let's say the New York site and London site. Okay, when you connect these routers using the maybe a lease line or dedicated line, do you care about any protection, any authentication, any confidentiality, any integrity? No, because it's secure. It's just for you. But when you use the public media, which is cheap, no doubt, and you can use, rather than as a private line, you can replace this with the with it. Okay, so now if you talk about okay, so what is confidentiality? Anybody has an idea about confidentiality?
Confidentiality mean, I mean the key should not know somebody else. I mean, password.
Just generally tell me. Don't worry about it.
Secure. Confidentiality means data is secure.
Okay, so these are as we discussed. IPsec is a framework. It use the IP protocol, and it provide the confidentiality, it provide the integrity, it provide the authentication, and of course these are the different by using these different protocol parameters and protocol and choices. You can see that. You can say, okay. Now, what is confidentiality? Just the overall definition. How you say confident? When you say sometime the top secret agent, sometimes you say 007. You say this data is very confidential. What do you mean? Top secret or top confidential file, for example. So what does it mean actually? How they ensure confidentiality? It's mean the less number of people should have access to it, number one. Also, if somebody read the data, that data should not be in normal readable format. Let's say if the data is hello, okay, but maybe it's written in AX1, different symbols. It's like a garbage, you can say. Clear? So we achieve the confidentiality. So once somebody can read it, doesn't matter, somebody can read it, but as long as they don't know what is the actual message inside, we achieve the confidentiality. And confidentiality we use by using DES, triple DES, AES, and all these protocols we can use. We can achieve confidentiality. Integrity. What does it mean by integrity, guys? Anybody has an idea?
I think the integrity means is very important as well, because the data which we send it to the receiver, it should be received by receiver integral, without maybe is on the way it's lost packet some, that way we can use MD5 hash.
Yeah,
packet.
That's fine. I'm not talking about the hash. I'm just talking about generally English language. What is the general understanding of integrity? Shabakat, what do you think? What is integrity in general day-to-day languages? What is integrity?
Integrity mean like credibility or
good. Good.
Something like that.
Yeah, let's say for example, I say you are my friend, and I say you are a thief, but actually you are not, right? And as a result, you say, oh, openly in a newspaper, you said I'm a thief, so I will go into the court. You have actually put my integrity in a risk.
Yeah.
So I'm tempering your personality. You got the idea? What I'm trying to say. So I'm trying to temper your identity. You are a very nice gentleman, but I'm trying to temper your. So in that case, sometime you heard in the newspaper or anywhere, this guy tried to ruin my integrity. I'm not like this guy, but I'm a very good guy, and he's something like that. I will sue you. I'll go to the court, and we will decide there.
Goodwill, like that.
So what happened? Let's say in a bank transaction, if I send you $100 and you receive $100, you just receive $100. You just receive rather than $100, somebody changed to $1,000. It means somebody received the data, and not only he received it, he tempered as well. Right? He tempered as well. It means that integrity of that data has been compromised in that sense. Okay? But if you want to achieve that, okay, somebody can read my data, doesn't matter if we want to confidentiality is there, but nobody can actually alter my information. How we can do? MD5 and SHA. So how we do that, whatever the information we send across the two parties, okay, we do these two protocols or these two mechanisms, MD5 and SHA, and we attach a hash value. And when this guy receives this guy on the other side, it again recalculates the hash value, and whatever the attached value it was there, it also received the same hash value. It means that data in the transit part has not been tampered. That's the guarantee. And IPsec provide you the guarantee using the MD5 and SHA. If you need integrity, use MD5, use SHA. Clear?
Yeah.
Okay. Authentication. How we can authenticate? When you log into Yahoo or Hotmail or Google email, what do? You assign the you send the username and password. That username and password is authenticated by a Yahoo, Gmail, or Hotmail server. Clear? If your key or the password is not correct, you will not be able to access your data. You will not be able to see your email. And that will be assured by using the pre-shared key or RSA signature, which use the certificate, which is used by the browser nowadays when you access your banking website, PayPal websites, for example. It uses the signature. But here we will be talking about the pre-shared key, which a two-party, my password is Cisco, okay, and his password is Cisco, both can actually authenticate each other by using the same password. Clear?
Yeah.
Okay. Diffie-Hellman, of course, this is the key mechanism which we use to actually achieve all these things. Right? So are you clear about confidentiality, integrity, and authentication? these confidentiality and integrity and authentication, if you achieve it, if you by using the public media, if you can achieve confidentiality, integrity, and authentication, you are good to go by using the public media, and you can communicate securely. Clear? Okay.
Yeah.
Any question? Okay. How we can achieve confidentiality? By using these. Okay. The difference, this is 56-bit K, this is the 3 times 56 bits, and this is 128. But the longer the key, it means it is hard to decode for anybody who intercepts that. Keep in mind the dash has been broken a long time ago. Okay. So most probably we will be using AES in our lab. Integrity, how we use integrity? By using the MD5 and SHA. In case of MD5, less secure 128-bit, and SHA is more secure, this is 160-bit. Okay, authentication, pre-shared key RSA. This is also, you can see, by another mechanism of using the. So confidentiality, integrity, authenticity, once you achieve using the public media, this is called a public IPsec VPN, right? Diffie-Hellman group is the key mechanism. Okay, RSA signature we're not discussing yet. So Diffie-Hellman groups is like the group. Okay, now this is, remember, I will tell you in few things, one of the most important things. Now, IPsec framework, as we discuss about IPsec framework, it's normally IPsec framework is a protocol. It's authentication. You use 2 protocols to achieve these things. Number 1, you use AH. What happened in the AH? There is no confidentiality. It guarantees 2 things. Number 1, it guarantees authentication, and it guarantees integrity. 2 things by using the AH. So somebody if asks you what is AH, authentication header, it means it does not provide you the encryption. Yeah. Right? If you need encryption, authentication, integrity, use ESP. There are 2 protocols at the network layer. Here, these 2 protocols, by using these two protocols, AH and ESP, we actually achieve the authentication. We can achieve the 2 things. Number 1, we can, by using the AH, we can make sure we can achieve authentication and integrity sometime. If your router does not support, on the other side of the router does not support encryption, you can only go for these AH. Okay? So in some cases, it can happen. So be aware of that. So everybody is clear about?
Yeah.
Tell me what is AH and what is ESP, guys. I blanked the slides for you.
AH, there is no security, only.
I mean, only authentication and integrity.
So it does not provide you the
confidentiality.
Confidentiality. Yes, it does not have encryption. So confidentiality is not there. Listen, for example, if I'm trying to transfer $100 or £100 to Shafaqat, and Shafaqat $100, right? If somebody in the middle, let's say Oleg is sitting in the middle, and if he say, okay, Mr. Mazhar and Mr. Shafaqat, they are actually sending $100 to each other, but he cannot modify it, right? Right? He can see it. He can see what is going on, right? It's in the clear text, but he cannot alter it. So even this will work as well. You got my point, actually, what I'm trying to say. So as long as somebody cannot temper it, somebody cannot change it. Integrity means somebody can alter it or somebody cannot change it. So which is also fine. You got my point?
Yeah.
Okay. So it depends upon the different scenario, but you need to understand what is different between AHA and ESP. Again, ESP, AH does not provide confidentiality. ESP provides you the confidentiality. Okay?
Yeah.
Clear?
Yeah.
Let's go. Okay, authentication header, as you can see, this is the header of this. It's just attached the one header and other side. You can see this is the hash value. If you get the same hash value, you get the integrity. ESP, as you can see, get all of these 3 things. Okay. Functionality of the ESP, we're not interested in that. Tunnel mode, there will be there are 2 types of modes of VPN, tunnel mode and transport mode. In the tunnel mode, the new IP header attached to it, right, in the transport. So what normally the default mode in most of the VPN, IPsec VPN is a tunnel mode. In most of the time, in some cases, we use transport mode. There's no different. You get the same thing, but the tunnel mode is more secure. Is actually you attach a new header. That's the only difference. And where we use normally, when you have two different endpoints, mostly on the internet side, you will use tunnel mode. Transport mostly used between the LAN to LAN.
For the internal networks?
Yeah, kind of. Okay. So mostly default mode is tunnel mode. So we don't need to worry about that. Okay. What is security association? Of course, using all these parameters. Okay, when you combine all these parameters, it creates a security association for you. Okay. Okay. Now let's come back into the phases. IPsec work in two different phases, and I'm going to give you one example. Hopefully you will never forget what I'm talking about. So let's say Mr. Cameron, which is no longer a PM for UK, and he wants to go to see Mr. Mr. Cameron now. So let's say Theresa May, she wants to go to see someone in France, so Mr. Prime Minister of France, for example. So what happened? Normally, when the high delegation go from one country to another country, tell me the steps. Do you have an idea? Let's say, just give me an idea. For example, what happens? Because she's a VIP. Let's say she's a VIP. She needs security. She's a very important. You can say she's a very important data of UK government, for example. Okay, she's a PM. So she wants to go from UK to France, for example, or maybe USA. Tell me what normally would happen. What is your idea?
Confidentiality, because there should be a confidentiality, because very less people know the meeting about that.
Okay, good. Anybody else? Some of the things that, for example, you know what happened, my idea would be, like, for example, these things happen in the two stages. Number one, first of all, two agencies on the high level, they talk to each other, they discuss about, or for example, that's my idea. I'm just hypothetically giving an example. Hopefully, few things might be similar like that. So two agencies of France and UK, they will be talking to each other. Okay, one of the most important data coming into your country. How will you provide the security? Okay, she will be landing on this airport. Who will be picking up? Which car she will be sitting in, behind the car, and after the car, how many people will be there? How much distance it will be from one car to another car? Which hotel she will be staying in? The hotel, what will be the security? When she go outside, what will be the security? When she eating, what will be the security? Who will be around? Something like. So these are all the negotiation parameters. Make sense? Yeah. So before you even send the data, or before even Theresa May has fly away to France, she need some kind of negotiation need to be happen, because both the parties, both the countries, both the agencies, they need to satisfy each other. Okay, what kind of security they will be providing, because of course she is very important, right? So this is the same thing happening in IPsec as well. So it has two phases. Before we actually send the data, before me and Shafkat send the information of £100 or $100 information, or send each other $100 each other, we need to agree some kind of parameter to each other. Okay, who are you, for example? Okay, how can you authenticate? You will be using the pre-share key. What will be your, you can say, what will be your encryption method? What will be your hashing method? What will be your pre-shared? You will be using pre-share, or you will be using RSA. What will be your authenticator method? So keep in mind, before we build any tunnel, we need to have phase one, exchange information. That's the first stage. If you remember, for example, Pakistan nowadays is struggling from cricket team point of view. They have kind of attacks in Sri Lanka, and I think recently, a few years back, if they want to play there, they send Zimbabwe went there, I think last year probably, and they sent their high delegation to check the security. Before even Zimbabwe team fly away. Yeah, just give an example. I hope you understand what I'm talking about. Is it clear, Shafkat?
Yeah.
Right? Making sense, right? Yeah. So the actual information is not exchanged yet. But before that, that's the phase one. If the phase one is not completed, troubleshooting point of view, very important. If the phase one is not completed, actual data will never be sent. Right? If there is a disagreement, let's say I'm using DES and they are saying, no, no, we are using 3 DES. If I'm saying we are using SHA, they said, no, no, we are using MD5. We don't want to send any data. So these parameters must be, first of all, you need to agree upon. So that's a phase one. That's why it's called IKE, Internet Key Exchange. Okay. So first of all, these parameters, as you can see, policy 1, policy, whatever the policy number, 10, 15, whatever it is, they say DES, MD5, pre-share key, DH1, and lifetime. So these are the parameters. What are the 3 parameters must? DES, MD5, pre-share key. Okay, and DH. So these must be matching. If any of the parameter is missing, it will be, come on. The phase 2 will never start it. Right? So phase 1 must need to be completed. Clear?
Yeah. Like you have created one tunnel,
yes,
and
yes.
one end you create one password, another end you create another password, it will not work.
Yeah, so you can see that's the IKE negotiation parameter. So now in the second phase, this is the phase 1 as you see going on. And this second phase 1, aggressive mode or the main mode. I will tell you what is the aggressive mode actually. There are 2 modes in phase 1. And number 1 is aggressive mode and main mode. In the main mode, you exchange 6 packets. Whatever the things you are exchanging to each other, you are exchanging this with the 6 packets. In aggressive mode, you can do the same thing, but with you can do within the 3 packets. That's the difference. Okay. Clear? Another difference is aggressive mode mostly we use for the remote VPN, and main mode we use with the site-to-site VPN when you one site to another site. Okay, one office to another site. Phase 2. Now, if the phase 2 is completed, now the negotiation parameter between the France and UK, it is fine. They said okay, and both the parties are agreed. Okay, we are satisfied with whatever the security parameters you are providing to our high level delegation. We are fine. Now we are happy and ready to send the actual information. That will invoke the phase 2. Okay, and in the phase 2, what we need to do, you see, IKE negotiation match IPsec policies. That is IPsec. Okay, before that, phase 1 was IKE, and now it's IPsec. IKE negotiation matching IPsec policies. Upon completion, a unidirectional IPsec security association are established protocol and algorithm combination. Okay, so keep in mind from when the IKE association happened, phase 1. In the phase 1, actually, in IKE, there is a bidirectional communication. Mean if the session is open from R1 to R2, return traffic is also allowed because it's a bidirectional. Clear? In the phase 2 IPsec, there is a unidirectional tunnel. Okay, which means one tunnel from this side and the other tunnel, 2 separate tunnel will be established. Okay, that's the difference in phase 1 and phase 2. Clear? Okay, host A send interesting traffic. Okay, now we don't send all the traffic in the IPsec tunnel. We only send the traffic which we need to secure. For example, in your office, maybe you have many networks, but you only establish the IPsec tunnel between the few hosts, a few networks, maybe 10.0.1.3, 10.0.2.3. They need to match to each other. We don't want to send the traffic for all the hosts in your network. Okay, because keep in mind, when you do encryption, when you do integrity, when you do pre-share key, all these parameters when you exchange, there is an extra load on the router or on the firewall, whatever the device you use. Okay, these device and these device, extra load. They need to do a lot of processing. They need to do encryption. They need to do re-encryption. They need to do hashing. They need to do de-hashing. Most of these things need to be done. Okay, and it adds extra load on the router. So we only send the traffic which we need to encrypt. Maybe we just exchange server traffic we just want to encrypt. Maybe just telnet session we want to encrypt. So it is depends upon us. Our policy will define that. Clear? So how we can see in the phase 2, the security association will be built up between the interesting traffic. R1 and R2 negotiate the phase 1 session. So I phase 1 is completed. R1, R2 negotiate the I phase 2 session, which is AH and ESP, things like that. And then they exchange the IPsec tunnel parameter, and now the tunnel is built up. Tunnel will be terminated once the data is exchanged, or it depends upon number of bytes, or it depends upon minutes or second. Mostly by default thing is 1 day, 3600 seconds, and after that the tunnel parameter need to be negotiated again. Clear? So some of the very important, okay, this is not related to your tunnel of your between which our topic is, which is Cisco ASA to Cisco ASA in our network. But this is just to give you a very quick idea how we configure on the Cisco routers. I know you guys have done on the checkpoint, but this is just to give you an idea about the IPsec tunnel built up on the Cisco routers. Okay, Cisco router to router. So what we need to do, these are the checklists we need to perform. Ensure that the ACL are compatible with the IPsec. Create ASA camp policy, configure IPsec transform set, create crypto ACL, and apply the map. So these are all the parameters you defined before. Now it's a time to, you can combine them together. Onik, you clear about that? Any confusion? Yeah. So last time I think you guys have done the IPsec. I remember with Yogesh. You remember that, right?
Yeah, we did.
Yeah. So is it like more, you know, kind of refresh things, or I was expecting you should know that, but just quickly before we can do, because the problem is that IPsec is one of the hardest topic in the networking world. Let me tell you. Okay, not maybe hardest, but it may be hardest to troubleshoot when it comes to the problem. Okay, most of the company, wherever you go, whenever you go to the environment, they will really greet you about this technology. And honestly speaking, I read about many RFC, and I would recommend you to read the RFC as well if you really want to understand the IPsec. It's one of the really difficult topics. Let me tell you. Okay. So, do you think is he much better now? Do you have more idea about now, or is it different than what you learned last time, or is the same thing?
It's like same thing.
Yeah, same thing. But any difference you found today, or maybe the last time? Fakat? Anyway, this is just a Cisco, but last time you did the checkpoint.
Yeah, but the platform is different, you would say.
Yeah, but the configuration point of view, the steps point of view, most of the things are different. The parameter like the I phase 1, I phase 2, traffic, apply them and combine them together. It's just like the same concept, like, but maybe the step wise is different. They have
even the companies use the checkpoint, but they use for the side-to-side VPN as a firewall.
Yes, it happens. It is happen. Mostly companies use 2 to 3 firewalls, at least 2 to 3 firewalls, and most of the time, especially Cisco is quite good for the VPN. And I've seen many companies across when I provide.
Cisco, yes.
Yeah, they use Cisco. So, but let me tell you, Cisco is more command line, so you will be sometimes. It's really hard to troubleshoot sometimes. Anyway, so number 1, make sure the compatible access list. However, ensure that the protocol 50, 51, and UDP 500 ISA traffic is not blocked by the incoming ACL. When you have ACL applied anywhere on the network coming into your routers or going from the air, make sure these protocol AH, ESP use the 50, protocol 50, AH use the 51, port number 51, UDP is 500. They should never be blocked in the transit path. If these are the block, if this is the block, then it means that I phase 1 will not complete it. If the I phase 1 will not complete it, I phase 2 will never be negotiated. Clear? So make sure these, if you have an ACL, make sure they are between the 2 endpoint, port 500 is open. And also port 51 and 50 is also open, because AH, remember the AH and ESP we discussed? What is the difference between AH and ESP? Quick one, hurry up.
Confidentiality.
Yeah, good. So who provides the confidentiality, AH or ESP?
ESP.
Well done, well done. Interview question, guys, very well done. Okay, for example, there are two routers, 772.30.1.2 and 172.30.2.2. These are the endpoint, like the gateway. And you have these two guys, you want to build the tunnel between 10.0.2.3 and 10.0.1.3, the different network. And the tunnel will be coming from them to this. Yeah, between these, sorry. Between these two endpoints. Yeah, and the tunnel will be built between the, the tunnel will be built between these two only. This is the IPsec tunnel will be built. The data will be encapsulated inside the tunnel and then come across, and it will be encapsulated, and then it will be forward to these guys. Yeah, that's all. That's all is not in. Okay, so how we can build the tunnel? We remember that this access list, you talk about AH, ESP, UDP, they must be not blocked in the transit path. If you have an access list, okay, make sure the ASA camp and ESP and ESP must be allowed between the two endpoints when you want to build the tunnel. This is where the crypto ASA camp policy, it's just like we are building the policy. This is the phase one actually, IKE parameters, okay? And in the IKE parameters, what we're doing is a policy number, we have given the number, and this number will be locally significant. Pre-share key, we're using the authentication, DES encryption group, Diffie-Hellman group, and hashing. This is hashing, this is encryption, and this is the authentication parameter, and this is the key, Diffie-Hellman group key. This is 8640. I told you the tunnel will stay up for up to 1 day. 8640, I think if you multiply to your, I think it's around 1 day, I believe so. Calculate this if you want to. Yeah. Okay. Then the next phase is these are the encryption parameters. These are the different parameters of ASA camp. We have encryption, hashing, group, lifetime authentication. Okay. What is the difference between when you say you can see what happened normally? The policy, like in access list, when you create a policy, it comes from the top to the bottom, 1, 2, 3, 4, whatever it has. For example, first of all, it will give it has created different proposal. One proposal is MD5 and pre-share key only. One proposal is SHA and the other is RSA. One proposal is MD5 and pre-share key. So what happened? Whatever it will first of all it will suggest this is my first one, this is my second one, this is my third one. Whichever will be matched, it will select that. If nothing will match, it will deny the IKE phase 1. Okay, is it clear why we are using this 100, 200, 300, 100, 200, 300? These are the sequence number of the policy. We can have multiple parameters. For some side we can use MD5, for some side you can use SHA, sometimes you can use DES, sometimes you will use triple DES, sometimes you use AES. For example, on the end client, if you have a very, very small router and it does not support AES, there is no point using DES because it will be denied. So that's why we use different kind of sometimes you can see the different kind of proposal. Okay, proposal 1, proposal 2, proposal 3. So whichever will match, you will go for it. If it doesn't match, you will not select. Okay. So far, any question?
What is this lifetime? Is it the session?
Lifetime, I told you lifetime means that how long the tunnel will up. And if once the tunnel is finished, you will need to renegotiate the tunnel parameter again. Yeah. Okay. It's a configurable. But what happens if this is let's say 1,000 and this is 10,000? This is still not a problem, right? It does not need to be matched.
So, Madhava, it will be disconnect after this. Given automatically, it will disconnect.
Yeah. Yes. Exactly. Yeah. You're right. After a certain period of time, the configurable is configurable actually. Okay. There are two configurable parameters. Either you can say okay, number of bytes or number of seconds. Clear? Okay, crypto ASA camp key, and now this is the key. We are now, first of all, we define the parameter. Now we actually need to define the key with the address on the other side. Okay, so we use this command crypto ISACM key, and the host name. Okay, yeah, you can see crypto ISACM key, and then you are giving this host name. This guy will be giving this endpoint. This guy will be giving this endpoint. Okay, just go on. Then this is the task number 3, transform sec IPsec parameter. Here we are using the AH or ESP. That's what we need to define. Transport, we need encryption, we need authentication, we need hashing, whatever we need. AH, or we want to use ESP. That's how we combine of that. Again, these parameters can be different as well. Sometimes use DES. This is, you can see a 3 DES. This is triple DES. This is DES. Triple DES. This is DES. Okay, this is ESP, and this is ESP MD5. This is ESP DES, and this is AH SHA. So whatever will be matched, you will be accepted that. The 9th attempt found the match transformer set of Charlie yellow. You see, that's what you see. So for example, he proposed this one first. Alpha, ESP 3 DES. He said, no, I have ESP DES. He said, no, I will not accept that. He said, beta is blue. He said, okay, ESP DES, fine. AH, this side is using AH and this side is using ESP. So it will be not matched. But now what happened at the end? ESP3 DES, ESP3 DES, ESP SHA MAC, and ESP SHA. Now this is the parameter are now agreed upon. So this means that the tunnel will be built up between them. If nothing will match, there will be no tunnel. Clear?
Yeah.
Okay. Then what happened? You need to create, this is crypto IPsec transform set. What is the name of the transform set? And the ESP and things like that. Okay. Also, that's very important, guys. The crypto ACL. And what is crypto ACL? You need to define the interesting traffic for which you want to invoke the IPsec tunnel. As I said, the IPsec tunnel you don't build for everyone. Maybe your boss to another boss, or maybe for certain devices you want to secure them only. So what you need to do here, access list, you need to define an access list from here. Number 1, let's say who is interesting traffic from our side. Tell me, guys, who is our interesting traffic? For the tunnel. For the tunnel, we have 10.0, 2.3 and 10.0. So your access list will be, right? This is source, this is destination. Right? From this side, this is source, this is destination. Okay? So in this access list here, at this router, you need to say this is source, this is destination. From the other side, from this side, right? This will be source and this will be destination.
It can be different, yeah?
It's like mirror access list. Remember, whatever the source on this side and the destination on the side, the other side will be opposite.
Mm-hmm.
If this does not match, IPsec will never come back. The IKE phase 1 can be completed, but IPsec tunnel will never build up. Communication will not happen. That is most common problem. Clear? Exactly. You can see here, for example, on R1. What is R1? This is the R1 side. This is the router, sorry, R1. On the R1 router, we have this list. 110, permit, TCP 10.0.1.0, going to 10.0.2. Clear?
Yeah.
Okay. And on the other side, you are on this router, you are saying maybe different access list number. That's fine. It's because it's local to one router. Source will be 10.0.2 and destination will be 10.0.1. So equally, you see this is a mirror access list. Okay. Clear? Now, all these parameters you define, access list, transform set, SA association, and all these things. Now you need to combine them in the crypto map. So Cisco called this is a crypto map. I don't know, what checkpoint at the moment. It's not on top of my head, but what they call. So, but anyhow, so you need to match the access list, and then you say, okay, based on this access list, what are the parameters, what you want to do with them. You are putting in the tunnel, actually. Encrypted traffic, router interface, or sub interface. So remote VPN, who is my remote VPN, transform set, key management, and live association with them. Okay, so this you can see here again. Yeah, crypto map, IPsec tunnel, and sequence name again. I think let's go to the example of next page. You can see here. So matching the access list, which you defined before in this router, set peer, which is the remote site 172.30.2.2. Yeah. Yeah. And then set peer with this. Yeah. And then PFS group. Anybody knows what is PFS?
Peer is the next.
No. Perfect forward secrecy. What happened when the tunnel negotiation, when the tunnel time is finished, for example, and the tunnel is need to re-establish, they renegotiate the new keys again. Okay, they don't use the existing key which was negotiated previously. They will it add extra security on top of it.
Okay.
Yeah, because you don't need to renegotiate the existing keys. Okay, and then the transform set you have created. This is like, again, it's optional. Okay, and then you need to apply this crypto map onto the interface of the router. This is router to router tunnel. Okay, our topic is actually show crypto map. This is on the Cisco router, show crypto map ISAC and policy, and the transform set and the SA, show crypto IPsec SA. Check the first phase 1 is completed. Yeah, so this is phase 2, sorry. This is phase 2. Show crypto transform set, show crypto ISAC and policy. Okay, so these are the different commands. This is the how we can set up. So far, any question, guys? So I think we covered the theory. Any questions so far about IPsec? If not, then we are going to create the tunnel. Okay, you can see the screen? Okay. This is the topology we will be using today to establish the IPsec VPN tunnel between two Cisco firewall. So 172, ASA 1 and ASA 2. It's not 50. It's, I think I use the same within the one firewall, ASA 1, ASA 10, and 20. I already built the tunnel, but I will just, first of all, let's just understand the topology first of all. So what happened, we took two firewalls. So one firewall is Cisco ASA, the other one is a Cisco ASA. And what will happen, we have two switches actually, which is 90 and 92. Okay, we created some loopback for our interesting traffic. Yeah.
Can we do the IPsec tunnel between two different vendor firewalls?
Yeah. That's very common.
Okay.
Yeah, it's happened. For example, you are using Cisco on the other side. The third party is using a Checkpoint, Juniper, Palo Alto, Fortinet. Of course. This is 99.9% of the cases happen every day. Every vendor compatible with No. Yes, configuration, because it's a standard. The IPsec is a protocol suite. It's a standard, is used everywhere. But of course, they will configure their side and we will configure our side. But we will agree upon the parameters. We will say, okay, what will be the phase 1 parameter? What will be the phase 2 parameter? Are you using DES? Are you using ESP? Are you using, encryption, hashing, whatever the method you will be using? So we agreed upon them. What is your gateway information? They provide you their gateway. We provide our gateway. Okay, to each other. And we provide, okay, these are the interesting traffic, these are the interested networks we need to give you the access to.
Okay.
Yeah, that's very common. That's very common practice. Okay, so as I said, in our network we have this switch. As you can see, this switch is 90, and this firewall is 10. Like the network is 192.10.1.10, and the other side is 10.1.11. But the traffic IPsec tunnel, we are initiating 192.168.1.1 and 192.168.10.1, right? And these are configured on the switches. These are layer 3 switches, so don't worry about that. Okay, what happened normally, we need, and also these are the endpoints. The firewall is connected, one firewall is connected to 10.201.10 and one is connected to 201.11 network. So two different networks. So this is his gateway, this is his gateway. So they will build the tunnel between this gateway and this gateway. Clear? That's a gateway address. Also, and in addition to that, on the Cisco ASA firewall, God knows what is the problem, even though we have a default route to this router, which is our outside router. But I also configure the static route. So from this guy, I can reach to endpoint, and from this guy, I can reach to this guy as well. For this guy. Clear? And also, because this firewall is a layer 3 mode, and this route switches into layer 3. So to reach that, this firewall need to know what is 192.168.1.1, where it is. So I think we already given this to. If you want to send the traffic to 192.168.1.1, because it's not directly connected, it is on the other network. Clear? So that's why we on the firewall need to know, if somebody asks me how I can reach to 192.168.1.1, I need to forward it to 10.1.11.2 on this switch, which is switch this one, 192.168.92. Yeah? Clear?
Yeah.
On the firewall point of view, this is the firewall we have 81 and 80. Keep in mind, this is the physically same firewall, but it's virtual context we already created. Remember? And you can see the magic. The IPsec tunnel is going physically from one firewall, but actually logically there are two firewalls. Is it clear?
Yeah, context, yeah.
Yeah, context. So there are two physically, logically they are separate firewalls, right? Okay. So far, are you clear about that? Topology is okay, making sense to you? Why we create the static route on the R route to inside network, and the one is for the outside network to reach to this network,
Where the netting will happen?
Wait. We'll come back. Yeah. Okay. And then this firewall need to know this guy, and this firewall need to know this guy. That's why we configure the static route from this firewall back to this side, and from this firewall back to this side. That's why I'm telling you the topology. Also, this firewall need to know the endpoint or the gateway of the other firewall, and this firewall need to know the other firewall. So that's why we put this kind of static routes we put on this firewall.
Or we can create default route, yeah?
Yeah. We have the default route, but somehow it's not working. I don't know, right? I found the problem when I use even though we have a default route, but if I don't have the static route, it's not working. I don't know why. Okay, it should work. It should work because this guy is also a default. This guy also default is sent it to this router, and this router knows where these guys are.
Yeah.
Okay, but so far the topology is clear. Yeah. And this topology, you can access it from the, if you want to see on your side, you can go to the your folder, which is ASA folder, ASA topology, and you can see VPN topology. Here, you can see between VLAN 10 and 11. See that? Clear? Okay. And the end goal will be this. So now I remove everything. Once we build our network, this is kind of more logical topology for you. where you can see the tunnel will be built between the two end point from, yeah? You got it?
Yeah.
Yeah, and it look like they are directly connected. Yeah, that's the beauty of tunnel. That's why we call MPLS tunnel or GRE tunnel. When you ping or trace them, they look like they are directly connected to each other. They don't know the transport network. And the beauty is that these network, private network and these private network, they are not here on the transit path. That's the beauty of VPN, because they are going inside the tunnel. So on this, they must not be on the routing table of this guy. That's why the private network can be routable on the within using the public media, public network. Clear? Okay. So mostly company, what they do, the primary connection, they buy a lease line, and for the backup side, they use the IPsec tunnel from the side to side from the office. So if the primary goes down, they kick up the backup for the over the IPsec tunnel.
So is that manual failover or is it automatic?
No, it's configurable. You do different techniques, which is not scope of at this time.
No. For example, it's something.
Yeah, it happened itself. It happened itself. From the routing point of view, it happened. Yeah.
No, it's automatic switch to the other.
Yes. How can you do this?
I don't know.
It's a scenario question for you. If somebody, you go to internet, somebody tell you, tell me if I have two destinations and I want to prefer this side and I want to prefer, I will use the backup. How can I do that?
Need to do some configuration somewhere.
So let's say this is two links. Yeah, S1, S2. And you want to reach from one side, you have two links. So this is the primary, this is backup.
Okay.
How can you do that? It's an interview question.
HSRP, I mean, you can do.
No.
Depend.
All right. Yeah.
Kind of resiliency method the company using.
Yeah. What?
For example, on the switch level, I mean, if they are switching using the HSRP.
Let's say this is. Don't forget about HSRP. HSRP provide you the redundancy at the LAN level.
Yeah.
Okay. This is default route. This is default route here as well. So you have two default route configured on this router R1. How can you do that?
F5.
Primary and secondary.
Sorry, Riaz?
Primary and secondary.
Yes, I know that. That's what I told you. You tell me how we achieve it.
What was the question? Sorry.
We need to configure on the R1 and the other side primary and secondary, which will be the primary and which will be the secondary.
So we just say you are primary, we just name it that you are primary and the router will understand?
No, it need to define.
That's what I'm asking you, sir. I'm saying you have two default route pointing to this side. Tell me, how can I achieve one primary, one backup?
Yeah, for example, one route, I mean, miss or lost, so the router will take the higher prefix one will take over.
What do you mean the higher prefix?
Priority.
No. Okay, how you can configure priority in routing in static routes?
Oleg.
I forgot.
What is this?
Active Directory.
AD.
Administrative distance. Higher administrative distance. That's why actually. Oh, I was thinking yes. Higher prefix, not higher prefix. Higher AD.
Yeah.
Or lower AD.
So this way, if this is a primary, you configure 2 static routes, default route, one side, you configure the lower administrative distance, the primary, and for the backup, you configure the higher administrative distance. So as soon as the primary link will goes down, the route will start, traffic will be flowing from the backup side. Clear?
Yeah.
Okay. Anyway, it was not a discussion point, but because the issue came in, so I just give you an idea. So how we can configure it, guys? Like right now, the configuration I have put here in the configuration example folders, right? So you guys have all the configuration example of NAT, captures, access list, OSPF, everything. I have put the configuration example here for you guys. Okay. Number 1, we need to configure outside interface. We need to configure inside interface. I hope we already configured it. Clear? Second phase, we need to configure the phase 1 parameter. These are the IPsec ASA camp parameter. Crypto IC 1, version 1, version 2. Now this is a new version 1, version 2 from version 9 we are using on firewall. So this does not allow you the using ASA camp, which was the previous version was using ASA camp, but now they allow you to use. They won't allow you to use ASA camp, but they will ask you to use IC version 1 and IC version 2, which is IC version 2 is more secure than the IC version 1. So you will say, okay, my method of authentication will be pre-shared. My encryption will be AES. My hashing will be SHA. Okay. Second phase will be I need to configure the transform set, and my transform set will be name will be ASA trans. For example, you can name it differently. It doesn't matter. However, these parameters AESP, ESP, AES, and ESP SHA. So we are using ESP protocol, not AH, which means we are getting authentication, encryption, and hashing at the same time. And hashing we are achieving with SHA, and in confidentiality we are achieving with the AES. Remember, DAS, triple DAS, and AES. These are encryption. SHA and MD5 used for the hashing. Remember? Second thing is we need to define the interesting traffic. So what will be interesting traffic for this guy? For this firewall, 192.168.10.1, sorry, 0/24, and destination 192.168.111.0/24. Clear? Yeah?
Yeah.
And we know in Cisco firewall, we don't use the inverse mask. We just use separate mask as it is. Clear so far? Absolutely. So far what we done, interfaces we need to configure. We need to configure the IC phase 1 parameter by using the policy. They can be number of policy differently. Policy 10, policy 20, policy 30, doesn't matter. You can configure many policies up to you. We configure the transform set. Third, we configure the access list. Yeah. Also, along with that, we need to configure the tunnel group. Okay, for the remote site address. Here, you need to define the pre-share key. Keep in mind, there is no space, and it should be matched exactly on the other side. Otherwise, your phase 1 will never be completed.
Yeah.
Okay, so tunnel group, and that this is the name of the tunnel or the endpoint IP address. Because mostly on the IPsec tunnel, they authenticate each other by using the address. They said, this is my address, this is my source address, and this is your source address. Okay, and my tunnel type will be IPsec LAN to LAN. IPsec attributes will be for this gateway, and I'll be using the IC version 1 pre-shared key Cisco 123. Now, all these parameters we define, crypto, transform set, access list, and these gateway, we need to match here with what? We are saying in the crypto map, it's like a route map. I'm not sure how many cars you know route map. So you say match. If you match with the access list, which is defined here, if anybody coming from here, set the peer address of 201.11.20. Who is this guy? Clear? This guy coming from here. This is my Clear? And transform set. This is the transform set we already defined here. You can, so saying if you match with this, if I'm saying this is the person, for example, on the security guard, I'm saying, okay, you know, if this guy is coming with this face, with this hat, with this at this time, can you please send him? And then what is the next you need to do? First, you are matching, and then you are trying to do some kind of apply some kind of policies to them. You're saying if the mass traffic is coming from this guy, send them to the next top IP of this gateway, which we define here. What will be the transform set? And this is the reverse route. I will tell you what is that. And then you need to apply this map to the outside interface. Clear? Also, you need to enable the ASA camp crypto, the first here. You need to enable this the I version 1 as well. On the Cisco router point of view, firewall, you need to also take care of few things as well. If you have applied, remember we have applied the inbound access list on this firewall. Everybody remember?
Yeah.
This one. Sure on access. How we can know what are the access lists applied on this interface? Sure on access group. With the help of this command, we know that this access list is applied to. Yeah?
Yeah.
Okay. Here. And if this access list is there, we need to check the access list. Show access list. And you can also, in the Cisco firewall, you say, yeah, this is my access list. Access list. What is that? Yeah, here. So I'm saying this is previously, remember we previously updated this access list, remember when the traffic was going from inside to DMZ? If you remember that, guys, right? We said coming from 10.1.1 going to DMZ. Yeah, database services they are allowed. Also, this time what we said, if it's not interesting traffic. Remember, it is not interesting traffic. But if we don't have this access list, then the firewall will drop it at the first time here, because the firewall check the access list first. Then IPsec and IC and these things comes later. If firewall does not allow this guy to come inside the network, it will be dropped here. Here. So if the access list applied, these are the optional parameter. I'm telling you, these are also need to consider. If the access list applied on the firewall here, and I'm telling you 99.9% in your firewall, in your environment, you will be having an access list if you are working in ASA firewall. So they already applied the access list coming from the LAN side going into DMZ or anywhere. You will be definitely having it. Yeah? Yeah. Okay. So you need to make sure that this traffic coming to this and going to this guy, it must be allowed. It can be IP, TCP, depending on what you want to do. Yeah, keep in mind. Second thing is, yes, also, remember yesterday when we were doing the static NATs, actually, we applied the access list on our outbound interface as well. This is out in, remember? Right? Riaz?
Yeah.
In this access list, you need to allow the ASA camp and you need to allow the AH and ESP as well for these gateways. Remember? So these are the additional parameters you need to know. If you watch CBT, anything other like that, or somebody else, they will not tell you these things. I'm telling you. So you need to take care of all these things. They will tell you how to configure access list, how to configure tunnel between two firewall. That's all. Simple. Okay. You need to take care of these things as well. Along with that, if you have a NAT, somebody asked me the NAT question, what will be happen? You need to configure the NAT identity NAT as well. What is identity NAT? Which means you don't want to do the NAT for these particular source and destination. Clear? Identity NAT means if somebody asks you what is identity NAT, it means you are not doing the NAT. Most of the traffic is going through the NAT coming from our internal network, but we don't want to NAT it. Is it clear? So these are the additional things you need to take care of that. Number one, configure interfaces. Number two, ASA camp, crypto map, interesting.
Will this identity NAT used in internal network, or because you said identity NAT is not used?
It's mean do not NAT. In previously 8.3, it was used NAT 0. NAT 0 and identity NAT in the new iOS, Cisco ASA, they use identity NAT, which means they don't want to send this traffic for the NATing. Clear?
Without NAT.
Yeah. So the traffic coming from this guy to this guy, it will not be NAT by these firewalls. That's what we want to do. I think you missed the topic yesterday and day before. Maybe that's why you are struggling with the NAT.
Sorry.
So apologize for that. You have to go through and for the videos.
Watch. Yeah, sorry.
Yeah, please. Okay. Are you clear? Yes. Are you okay? Yeah, so far.
Yeah.
Okay. So a lot of steps, and I think the problem is you need to configure two firewalls in your point of view. Whenever you build the tunnel, it is from, let's say you build one more tunnel with another destination. Unfortunately, you need to build another tunnel between them. So let's say you have another firewall tomorrow here, you will need to build another IPsec tunnel. Okay. Every site you will be having, there will be a new tunnel built up. Okay, from both sides. Okay, so maybe sometime, most of the time, you will be configure your side and they will be configured their side. However, from the troubleshooting point of view, you need to understand what firewall they are using, what parameter they are using. These need to be negotiated. I'll probably give you a form actually, which shows you what are the parameters we need to get it. I think, let me find out. I will maybe put it here. Okay. So far clear? Okay.
Yeah.
This is switch 1. This is switch 2. On the switch, actually, you can see on the switches here, 90 and 92, the firewall switches. I have configured some loopback addresses. Loopback 10, 110, 11, these, and you can build the tunnel between them. Up to you. You see, this is we are using for firewall 1, and this is we using firewall 2. Entirely up to you. Okay. So first of all, we need to make sure that these guys also on these router, they know 192.168 10 dot from the 10 point of view. From sitting on the switch here, I need to know show IP route 192.168.111.0. You can see I'm sending to firewall, which is 10.1.10.200. Remember that? We configure this, right? Clear?
Yeah.
Yeah, that route must be there. If firewall does not, if the device does not know the route, it will drop the packet straight away. Clear? Okay. Second thing is on the firewall, do the firewall need to configure the route as well?
Yeah.
Huh? Outside. And you can see this is 192.168.0.111. We don't need to configure that route. This is the result of this command. This. When we configure this command, and based on the access list, it automatically put the route in the routing table. It said, okay, if you want to go to now this guy, for example, this guy say, okay, tell me where is 192.168.0.1. It come to this firewall and it say, yes, I want to send it to the next hop is this, which is the tunnel.
It shows as a static. Yeah.
It shows as static. Yes. It put itself. This is the result of this firewall. This one. Okay. Crypto map. You can see that. Yeah. So let me try to remove it, and I'm sure this will be disappear. No. You see now? See?
Yeah.
Previously, it was there. But because of this command, firewall itself put this into the static route. That is the benefit of this command. So somebody in the interview asks you what is this command does. You need to tell him this put the static route for the tunnel. And now when you do that, show IP route outside, you can see now it put the static route clearly. And if there was no static route when we remove it, now we can see there is a static route here. Clear? Okay. So first of all, what are the parameters we have? Show, run, we have this interface, we have this interface. We need to, first of all, if you want to build the tunnel between the two endpoints, what you need to do? You need to make sure you can reach to this guy. How we can make sure? We can ping it. 200.1.11.200, right? Let me ping from here. 200.1.11.200. I can ping it. Reason is because show route outside, you can see I have put the static route to my outside router, which is this router, and this router then forwarding to the other side. On this side, show route outside. So both need to know each other. Yeah. See that? So that's the first criteria. If the gateway are not reachable to each other, forget about IPsec tunnel. That's come later. The routing must be there. And on the internet, when you build the routes between the two firewalls, they are connected to the internet. Of course, these firewalls already configured with the public interfaces. And if they're not, then you need to take care of that. Clear? Okay. So once you build the routing between them, what are the first thing? Yeah, show run crypto ASA camp. Show run crypto IKE. You see that IKE version 1. And this is my policy. So crypto IKE version 1, policy 10. Share key is authentication. What is this? AES. I can tell you. Let's configure one more crypto IKE version 1 policy. This time 10. You know, like in access list, we put the numbers. The number will be this time 20. Question mark. Authentication. Pre-share key. Okay. Encryption. What is the encryption method? AES, DES, triple DES. I say triple DES. Okay. Hashing. MD5 or SHA. You can see that. These are the two parameters. I'm saying MD5. Okay. That's all. When I do this again, show run, you can see I have now two policies, policy 10 and policy 20. On the other side, we only have one policy. Yeah, which is 10. So this side, let's say it has two policies, and this side has a 10 policy. Which will be proposed first? Tell me, guys.
10.
Huh? 10, based on the sequence number.
Yeah.
Yeah. If I want to delete that 20, let's say I'm deleting the 20. Yeah. And now, this time, I'm saying 5. Yeah. And I'm configuring these parameters. Five is above now 10. AES and SHA. This side, AES and SHA. But you can see my first policy is triple DES and MD5. Which will come first? Which will be proposal first one? So when you try to build the IPsec between the two endpoints, the 10 firewall will present this proposal first. And this guy will reject it. Then what happened?
Drop.
Now then firewall 10 will propose second one.
Excellent, excellent, excellent. If you have multiple policy, it will present first, second, third, fourth, until it's a match. if there is no match at all, then it will say no, sorry.
Mother, question: can we add in one policy?
Yeah.
For example, few encryption types on the same policy.
Sorry, what we can see?
In the same policy, you see, you can add encryption AES.
Yeah.
But can we add two on the same policy, two encryption type?
No,
or
only one. If you want to do another one, you need to create a new policy number.
But if there will be same encryption, it will be matched, but will be hash different. You know, like
yeah.
Yes, should be
policy 30. Encryption. What is the encryption method we have? Des, triple des, and let's say I'm saying here des. Yeah. Before that we use triple des, AES, and now we are using des. Hash, we say MD5. Authentication, we say use RSA signature. Right? This is my proposal. So it's up to me. I can make 10 proposals, 20 proposals, 100 proposals.
Yeah.
Now you can see when I do show run crypto IC phase 1, my policy 5 is using DES. This is using AES. This is using DES. They are using MD5. They are using SHA. They are using MD5. And they are using authentication. They are using RSA. They are using triple DES. They are they are using pre-share key. Clear?
Is this advantageable or disadvantage to have many policies? Because anyhow they will connect. If you have multiple policies, they will connect to any one of them.
It is an advantage in some cases when you want to connect to multiple sites. It depends upon the vendor. Maybe some sites they say no, we don't want to support MD5. We only use SHA. But if we say no, my router only support MD5 only, so they don't have any choice.
Yeah.
Right? It can happen. Maybe the lower end routers or switches, for example, or devices or firewall, if they don't support any feature, you negotiate to them. They said no. You remember the example I gave you, the two head of the state when they meet each other. That is the proposal 1. That is the phase 1. We are sending the proposal of different proportional. They say, yeah, my proposal is this. This is my first proposal. This is second. This is the third. Okay, choose whatever you like. And I will say, okay, these are my choices. I will go for that. That's my first proposal. Clear? Okay. So far is okay. Then the next one we need to configure crypto ASA IC version 1 transform sec. Yeah. Show run crypto ASA sorry, not ASA IPsec transform. Okay, and you can see there are many transform sets are already configured. I did not configure. There are many here. On this firewall, there is only one. Oh, there are many actually as well. I don't know. It's by default they are there. They are by defaults are there, right? So you can choose maybe the default one configuring. This is 128. This is 192. They are different proposal. Okay, but my one is ASA trans, which is ESP AES and ESP SHA, which is my this ESP AES and ESP SHA. So we are using that. Maybe we have many. Okay, that's where we are using AH or ESP. This is a decision. Remember?
Yeah.
Next one is configure the access list. On the access list point of view, show run access list. And my access list is this one. That's one. What he's saying, from the 10 side, from this side, this firewall, I have 192.168.10. So that's what will be my source. Source, when it's going to this guy for any IP traffic, that's what my interesting traffic I'm defining. On the other side, have a look, guys. On the other side, what will be the access list? Malik?
Yes.
Opposite.
Yeah.
This is source is 111. This is source 10 going to 111, and this one is going to 10. Exactly the mirror. If this is the source on this side, this will be the destination on this side.
On the inside interface inbound.
Exactly. Yeah. Clear? Once you define the access list, you need to define the tunnel group. Show run tunnel group. Let's say how we define the tunnel group. That's it. So tunnel group 201.10.200 type L2L, like LAN to LAN tunnel. Let's say I just want to show you the command. Tunnel group question mark. You can see saying enter the name of the tunnel group. On the Cisco ASA for site-to-site tunnel, we use the IP address of the remote site. If I'm sitting here, here my tunnel will be destination 200.1.10. Yeah, and then question mark, and I'm saying type. This is the type. It's not in the. It does not show you the command. And then the IPsec attribute, and then here you define the, for that destination I'm using this tunnel. You can see this key is encrypted format. It's not shown in. Yeah, but you need to know the key actually, which is Cisco 123 on both sides. Yeah. So this firewall, tunnel group 11 from this side is 11. Yeah, so both are defining the same parameters on the other side. Now the next stage, the final one, we need to actually do the crypto map, and crypto map name of the crypto map, which is this. Crypto map, and I'm matching, and I'm saying this is my access list, which is this access list. We created the mirror access list. Okay, I'm matching this. I'm saying, okay, if this is the access list, I want to set the peer other side. I want to use this transform set which we created above. Yeah. Okay, and I want to use the transform set. Then also, I don't know why this coming is, that's the reverse route. I told you what is the reverse route command. And then once you create the map, actually, you need to apply to the interface depending upon your requirement. In our case, it is outside interface. Most likely it will be outside interface connected to the internet side. Clear? Also, we need to apply the crypto and ASA IPsec version 1 on the outside as well. So this is the crypto map. Show run crypto ASA version 1. So you need to see crypto ASA version 1 enable outside. That's another key command you need to do. So 7, 8, 6, 7, 6, as you can say, 6 steps actually. Number 1, phase 1 policy. Number 2, transform set. Number 3, access list. Number 4, tunnel group. Number 5, crypto map. And number 6 is apply the outside interface on the ASA version 1 as well. And this. Keep in mind that only one crypto map can be applied on one access list, one interface, sorry. Yeah? I will tell you what this means. You remember what I'm saying is, if you need to build a new tunnel from here to another destination, what you will be do, you will be using a different number. Here we are using 10. So in your network where you go, you need to build the tunnel again. Do not remove this VPN, this crypto map, please, on the interface. Otherwise, maybe all the tunnel will go down. Because if you apply a new crypto map, that crypto map, like an access list, only one interface can have one access list, inbound or outbound. Similar, one crypto map can be only applied. Okay, so crypto map, let's say this, and you can see the sequence number. Like an access list or like a route map, you have access list, let's say 20, and I'm defining the 20 match, let's say address match address Cisco. Oh, it's not created, but just shows you actually. So you need to create a new number for that. Yeah? Is it clear? So far configuration is okay, guys?
Okay.
On the ASDM, it is also very, very easy. You can go to the firewall, select the firewall in our size. I am 10 actually. Let's say I'm going to the configuration. And in the configuration, you can see there is a wizard here. You can run this VPN wizard or site-to-site wizard. And you can say different VPN tunnels you can build from here. Okay, I will show you very, very quickly about that. Is it so far okay, guys?
Yeah.
Okay. I can tell you where the configuration has been. If you go to the site-to-site VPN, this is where the configuration of the in the ASDM you can see, and this is the tunnel I have already built out. Yeah, it's saying on the firewall. Let's say first of all, what is that? So 200, this is on this firewall, yeah, 10 firewall. I build a tunnel for my other, what is my endpoint, my gateway IP address, who's my local network, who's the remote network, that's the default actually, enabling IPsec version 1 or IPsec version 2, IPsec version 1 setting, IPsec version 2 setting, okay, pre-shared key or RSA, IPsec policy actually. IPsec version 1 policy, which policy you want to use. And this is my proposal. And you can have different proposal already there. You can select one of them, but you can create any proposal as well if you want to. If you want to go, you can say Cisco, for example, and you can choose test triples des or whatever. Tunnel group and transport mode. Mostly, I told you it's a tunnel mode. Yeah. These are some additional parameter crypto map entry. For example, number 10, as you can see, NAT traverser is enabled. Route injection. You can see this reverse route injection. I just show you the command which put the static route entry. Connection type bidirectional, main mode or aggressive mode. Yeah, and this is the tunnel group. Clear? Similarly, on the other firewall, which is 20, you can also see in the configuration and go to the site-to-site VPN here. We already, you can see that it's enabled. IPsec is enabled for that, the outside interface. When I double click there or I go to edit, you can see now who is my endpoint. So from this side, I'm watching the other guy now. Yeah? And that's why you can see the access list is totally different. Yeah, this is my pre-shared key where I define it. In some cases, if you want to exempt this from, I told you identity NAT, you can select this option, exempt ASA site host network from address translation, which inside network or where. What it does actually, it creates the entry of the show run NAT. Yeah, you can see inside to outside source is this, that's and this. You see that you are netting into the same thing. Destination is a destination when you go to this side, same IP, no proxy ARP, route lookup. So actually what you're doing, you're not doing the NAT actually. Clear?
Yeah.
Right. If I deselect that, if I let's say go to, this is my 10. Show run. Yeah, let's say for example, if I double click this and I say don't exempt the NAT, you will and apply it. You will see when I apply and save it, that command will go. You can see now, show run NAT. Now this command is gone now. Yeah, which is actually effectively you're doing identity NAT. You're not netting from when you're going outside inside for these guys. For 11, yeah, and going to 10. Okay, but it is better you don't put into the NAT. So once you put this into the exempt this from here, apply this, save, you will see that will come back. You see that? Clear? Is it clear, guys?
Yes.
Okay. Now the last thing is we need to check the traffic actually. The command we need to verify first of all. Show crypto ASA camp. Sure. You can see there is no tunnel built up right now. Okay, and I want to show you the messages those comes across. Okay, no, so not here. I'm going to the monitoring. First of all, I'm going to the 10 firewall, this firewall, and I'm going into the monitoring. I just want to show you the logs actually, what will happen when the tunnel initiated from one side to another side. Okay. So let's say what happened. Well, let's say I'm trying to build the tunnel. I'm trying to build the tunnel from, we already configured that 192.168.10.1 going to 192.168.1. What is my loopback 10 and what is loopback 11? That's between the host actually. So my show run interface loopback 10, and on the other switch, show run interface loopback 11. You see, I want to build the tunnel between these two. And when I try to tell ping it, 192.168.10.1, sorry, 11, which one? Yeah? This guy?
Yeah.
Let's see what happened. What is saying? Nothing. You see, nothing will happen. Why? No tunnel. And if we go to the, you can see there is no crypto map. Show crypto ASA camp SA, no tunnel. Show crypto IPsec SA, no tunnel. So crypto is a separate, ASA camp is the phase 1 and IPsec is the phase 2. You can see there is no tunnel. Why? Question, very, very important question, guys. Okay, look at the access list first of all. Traffic is initiated 192.168.10 going to 192.168.111. So why the tunnel is not coming up? There is nothing, even no log message. You see this? There is no even log message. Nothing is showing me here.
Phase 1 is not completed.
Even the firewall does not see the packet for this guy. If I ping from here, you can see it's not working. Firewall has nothing.
It is denied.
It's denied. Deny ICMP.
Access list.
You can see what is the source address. Look. Who is the source? 10.1.10.
Yeah, it's out interface from the switch. Yeah, it's not from the loopback.
Yeah, you see that? It's coming from this. As I told you before, when you ping to other side, it take the outgoing interface IP. Clear? That's why the firewall is denying that. It said no, and is going to deny ICMP source standard 1.1 outside going to 1.1. Yeah, it's denying, guys.
Yes.
So what can we do?
New access list.
Yes. See this? What happened now? Oh, sorry. This is.
Or change the source address. Is it?
Yeah. Yeah. Now see that my crypto tunnel came up. See that?
Because before that it was outbound as a source address.
Yes, you need to make sure, because you see the access list. Access list will only initiate the tunnel once the coming from this guy. But actually it was initiating when you pinging without source address, it using this guy IP.
Yeah.
So, but it's actually, I just created deliberately this environment, so just to show you. Otherwise, if you normally you don't need to use source, but because of our environment, just want to give you the concept actually. The traffic tunnel will never be built up until you
Provide the source.
Provide the source. So who is the source? This 10. When it's going to this guy? Eh? And this is the state I need to see. My one tunnel show crypto. This is the LAN to LAN tunnel, and the status is MM active. And my peer is 211.200. This should be the same on the other side. You see? Yeah. Also, show crypto IPsec SA. How many packets are gone and how many packets are encrypted? You see, that's very important. Clear? How many packets are gone in the encryption method and how many de-encrypted? They must be nearly equal. See that? And there is a wealth of information. You can see the two different, who is the access list we are using, source, destination, local, and the remote network. Who is my current peer with it? How many packets are coming? How many are failing? You see that? It's all the information. That's a very handful command, but it has a lot of information. Who is the endpoint? This is the ESP tunnel. You see that? These are the two ESP tunnel. What ESP method we are using? LAN to LAN tunnel. Is it tunnel mode or is it transport mode? Yeah. How many bytes are gone so far? Everything. Okay. So let's say I'm pinging continuously, and you can see the more traffic is coming. Oh, I need to resume it. That's why I was saying why I'm not getting anything. Okay, let me just delete the tunnel. How can you delete the tunnel? Clear crypto ASA SA. When you delete the tunnel, you will see this message. You see what happened? Session is down. Remote administrator reset. You see, that's tunnel is gone now because I manually reset the connection. Show crypto ASA SA. You have this firewall access, guys, anyway via VPN. So you'd be able to run all these commands. You see, now there is no tunnel. Tunnel will be only built up. You will see now what happened. Yeah, first packet is gone. And you can see that. Yeah. What happened? I was successful at the setup of the tunnel, which sequence number 10. Phase 2 completed. LAN to LAN tunnel from this 201.10 to 211, and an outboard access list, which is LAN to LAN, right? Sorry, this is something. This is IPsec. Sorry, this is the group. Phase 1 completed. Apply the group policy, group, and a wealth of information. So you can see in the message log, lot of information. Even you can see. You can telnet. When you do the telnet to 192.168.111.1 using the source loopback of 10. You see, sorry, this is 111. You see, I came from 90 to 92. Yeah. From 90 to 92, from all the way from here. Clear? And when I do show user, you will see this guy is coming from source IP. What is my source IP?
192.168.
Makes sense now? Clear? Huh? Shafkat?
Yeah.
Oleg?
Yeah, sure. It's okay.
Everything crystal clear, guys? So this is one of the hard topic. I told you in a very best possible way, guys. Okay? Any question? These topologies are there. What you can do now, right? You have the access to the firewall. I will give you the diagram.
Mother, do we have the same ASDM version? Because I can't see many options you are exploring. 7.2 I have.
Yeah, that's it.
But you know, this resume, if you can
it has a 7.2. Because if you select the logging level, it depends upon that as well. Okay. And also you can see this guy's monitoring. If you go to the monitoring, you can see the VPN and you can see everything from here as well. Crypto session, how many packets are encrypted, de-encrypted, everything you can see in the GUI as well. Go into the monitor, go into the VPN, and you can see from here. Okay. Is it clear now? So tell me, guys, how was the experience today? It's one of the difficult topic. And these configuration I told you, they are here in the folders of student folder. If you go into student folder configuration file, these are the two examples. By using these two examples, you can also build your topology. And your topologies are here. I just give you one topology here, one topology information here. Okay. And what I'm going to do, I'm putting the config topology VPN. Okay. Student folders, and I'm putting this into here in the Visio. Yeah, clear? I'm also putting a Visio for you. So you need to create the if you have a Visio, you need to create the diagram for yourself and create the VPN tunnel between two different firewalls. The loop packet are already created. The loop packets I already created on these switches. So do not touch them. But you need to go through all the steps. Make sense? Right? And then I will check all the things on the firewalls here if you configure the VPN. For example, I build the VPN between only this and this. You can build a VPN with different endpoint, maybe 10 to 12, maybe 12 to maybe 10 to another build the VPN between 10 and 12. And then you can check the routing accordingly. But I put the diagram here. You need to create your diagram. What you need to do, simply, the diagram is already provided. Yeah? Yeah, this diagram is already provided. Maybe what you do, you just simply need to change the IP addresses, for example. It's like a very easy to use, guys. It's not very difficult. I like mostly colors. So let's say I need to change the IP address of this guy. I will double click and I will, you see, I can say 12. Okay, and I save it, and I can save it something like that. Clear? Okay, if you select that, you can choose it. You can use different options from here. Okay, you can use these things as well. So